Hello and welcome to SudoKanard. Let's solve this killer Sudoku by Thomas Snyder. It was featured in the Sudoku Grand Prix round. And you can see that the cage totals all end with 8, which was the theme for the puzzles of round 8. And you can see that we have lots of 8 here, 8 here, 18, 28, and finally 38, and we go full circle, and another 8 here. So the special rule of Kira Sudoku is that whenever you have such a cage with a dashed outline, all digits must be different. Well, obviously all those digits must be different by the rules of Sudoku, but the rules of Sudoku would allow some of the digits in here to be equal, but the rules of Kira Sudoku forbid this. And then the number in the corner is the sum of all those digits. And then, where do we start? Well, here we have a total of 36. The sum of all digits on the row is 45, sorry, so that's a 9. Here 8 without using 1 and 2 is 3 or 5. So this is now 1, 7 or 2, 6. So 1 or 2 here, 6 or 7 here. And we know that 9 appears somewhere here, and by Sudoku we get the 9 here. 9 does not appear in here. It will be in one of those two places. And an interesting point here is that 9 is not in here, and it's 9 is not in here by the rules of Sudoku, and it's not in here because 9 already appears in the cage. So 9 is somewhere here, but not in this cage. So we get a 9 in here, and in the first column, 9 can only be in two places. It won't appear in there. If I, well, sorry about that. 8 with 3 digits could be 1, 2, 5, but this 5 just prevents this from happening, so it will have to be 1, 3, and 4. And in this case, this 8 can only be 2 plus 6. Here we have 5, 7, 8, and 9, so this is from 5, 7, and 8. What about this? I'm not sure what I could do. Something interesting in here is that those 3 digits are different from those 3 and those 3, so they must be exactly the same as those, which is called roping. So those 3 digits are the same as those, they must be the same as those. I'm not sure that will be interesting. Another interesting place to look is here. Those digits must be from 4, 6, 7, and 8. Is that really interesting? I'm not so sure. Well, in a way it is, because this 28 cage uses 7 digits, and 28 is the sum of the digits from 1 to 7. That's what's called the seventh triangular number. So this cage contains all digits from 1 to 7, so 8 is not in here. 8 is none of those. And now, that's interesting because 28 can only be 4, 7, 8, 9 or 5, 6, 8, 9. So we know 8 is in here. And the remaining digit here, if this is 4 or 7, this will be the other 4 or 7. If this is 6, then this will be 5. I'm not sure all that pencil marking was really necessary. Now 9 is not in here. We know that 9 is not in the cage, so we get a 9 in there. On this row, 9 has to appear either here or here. And something else that's interesting is that 8 does not appear in this cage, so on this row, 8 can only be here, so it puts the 9 here and the 9 there. Okay, 5 must be here. And that's a 1, 2, 4 triple. This here can only be 6 or 7. And up there they are from 6, 7, and 8. Now those 3 digits are 2, 6, and 7. And that's interesting because this digit can no longer be 6 or 7. It has to be a 4. And now we know that 4 does not appear here, nor 7. So that's a 6-8 pair, that's a 5. And with this 6-8 pair, that becomes a 7, and that's a 1. That's not a 1. And this now can no longer be 1, 7. It could be 2 and 6. It could be 3 and 5. 7 is not here, so 7 is there. And 7 is there. This cage contains all digits from 1 to 7, so the digits that we are missing are 1, 3, and 5. So that's 1 or 3, that's 1 or 5, that's 1, 3, or 5, and we know that 5 is among those. We get 5 down there. And something interesting is that 5 does not appear in here, so 5 must be somewhere in here. So that's the place for digit 5. What else? Here I need a 1 somewhere. I need 1, 2, 3, and 7. Here I get 16. I should have noticed this earlier. 16 plus 18, that's 34. To get to 45, we need another 11, so that's a 2-9 pair. And more precisely, 9 here and 2 there, so 2 is not here. That here is a 1-2 pair. That's not 7. This is a 4, 6, 8 triple, so that's a 4. That's the 6, that's the 8. That's a 7. That's 5, that's 3. Then 4, 6, 8 here. This is now 6. It results to 6 pair. 2 must be here, and that's a 7. 7 goes here. Here we need 1 and 4. So 5, 8, and 9 here. Where's the next place to look? This column has a lot of action already. Oh, this is no longer a 9, so that's the 9. I'm not sure where I'm supposed to look. I remember that was a really tricky part at some point. So those 2 digits must be around here, but I don't think that's the point. That's a 38 cage with 7 digits, so the 2 missing digits have a sum of 7. 5 is in there, so 2 must be in there. The 2 missing digits must be either 1, 6 or 3, 4. If 3 is in there, 3 will be here. And 4 will be somewhere there. That seems to work. If 1 and 6 are in there, is there anything that doesn't work? If that's the case, I'm not seeing what it is. So how do we resolve all of this? Oh, I'm seeing something. 8 must be somewhere in this cage. And because of this 8 must be here, and actually this digit has been sitting there right from the beginning. And 7 goes down there, so that's a 4. That's not. This is from 135. Now we still need a 2 somewhere, either here or there, and 2 digits from 2, 3, from... Oh, we now know that 3 is not in the cage, so 4 can't be in the cage, and the missing digits are 1, 2, and 6. And there is actually a 6 in here, so that this is a 3 with a 5, and that's 1, 3, 4. Oops, sorry about that. 4 and 1 here. No 5 in here, that's the 5. So that's 6 and 8 on top. 6 is here. This is now the 4, and that's the 2. That's the 1, 4, 2. Here I still need a 1 and a 9. So 9 here, 1 there. That's the 3. So 3 is not here, and actually it's not a 5 either. And then here we have 15. We need another 13 in the cage, so there must be 6 and 7. And that's the place for the 2. 1 and 2 up there. I could have found them more easily. 2 here. Here I need 4 and 8. 6 up there here, so that's a 3, that's a 7, that's 6, that's 7, that's 6, that's 7, 8 and 6. So finally here I need a 4 and an 8. And we get the last digits. That's it. So very nice construction with this killer Sudoku. Very nice use of the geometry of this cage. Most notably the fact that this needs to contain an 8 and that this 8 sees all the cells, but this one could have allowed me to place this 8 right from the beginning. And I remember placing it much earlier during the solver in the contest. Well, thanks for watching this video, and see you soon on SudoKanard.